In this video, we are going to discuss about geometric progression. In short, we call it as GP. Okay. Now, you all know what is AP, where you are going to add a common difference, correct? A plus D, A plus 2D, plus 3D, plus 4D, isn't it? Now, a geometric progression is that progression where we multiply a common ratio. That means GP is of the form AR, then AR square, so on and so forth, till AR to the power n minus 1. This is a geometric progression. Alright, the first term T1, T2, T3 till Tn. Or you can say A1, A2, A3 till An. Both are one and the same anyway. Alright, so the nth term or the general term, we can say nth term or general term of GP is AR to the power n minus 1. Alright, remember here R is called as the common ratio. Okay, R is called as the common ratio. So in this case, what we have the nth term formula AR to the power n minus 1. Just like how we had it in AP, A plus n minus 1 into D, right? Here it is AR to the power n minus 1. Now, whenever we talk about a geometric progression, I'll give you an example, simple example. Say we start by taking 1, 2, 4, 8, 16, so on and so forth. See, this is a GP because what is the common first? We'll take A value 1, very simple. What is the common ratio? R value is 2. Isn't it? See, 1, so the first number 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, so on and so forth, isn't it? So every number we are multiplying by a common ratio which is 2. So common ratio is 2. Fair enough? Now the next case what we have in this, that is the geometric progression, is the sum of n terms of a GP. Okay. Now whenever we have sum of n terms of a GP, there are two types. We'll discuss it now. Alright. Consider this sequence. 2, 4, 8, 16, so on and so forth. In this what we have, A value is 2, R value is 2, correct? So what you should understand is that R is greater than 1, correct? See, when R is greater than 1, then the sum to n terms of a GP is going to be Sn is equal to A into R power n minus 1 divided by R minus 1. Understood? A into R power n minus 1 by R minus 1. This is the formula what we use if and only if R is greater than 1. Okay. What if the sequence is something like this? Say you have 2, 1, half, 1 by 4, so on and so forth. A value is still 2, but R value is half, correct? You're dividing by 2, or you can say multiplying by half. See here, R value is less than 1, isn't it? Since R is less than 1, the sum to n terms of a GP will be Sn is equal to A into 1 minus R power n by 1 minus R. This is sum of n terms of a GP. Understood? Remember, these are sum to infinite number of terms, isn't it? Like let's say for 10 terms, 15 terms, something like this. So what we are looking at is one is called as increasing sequence, one is called as a decreasing sequence. Increasing sequence is where R is greater than 1. So this is basically increasing. R less than 1, decreasing. Okay, based on the R value, we have two types of, you can say, sum of n terms. But in GP, which is not there in AP, in GP, we have another set of numbers, or you can say sequence or series, where there could be infinite number of terms, and we can still calculate the sum of those particular n terms. Okay, infinite terms, not n terms, infinite terms. Now, this is a special formula. So, what we call this as S infinity. S infinity is nothing but A by 1 minus R. Very important. There is a condition for it. Condition is R value should be less than 1, cannot be greater than 1 or cannot be equal to 1. Has to be less than 1. Only then we can figure out S infinity. Clear? So these are the three formulas what we have for the sum of n terms of a GP. One is R greater than 1, one is R less than 1, one more is infinity. Okay? So this is about GP, geometric progression. Just like how we have arithmetic mean, we also have geometric mean. Okay? To do the geometric mean, so what we do, we'll take A, we'll take G, we'll take B. Okay? Very simple. Now, what do we have? The ratio is the same, correct? So, G divided by A is equal to B divided by G. Common ratio, right? Cross multiply. G square is equal to AB. So, G is equal to root of AB. So, the formula is G is equal to root AB. The geometric mean is root AB. What was arithmetic mean? Arithmetic mean was A is equal to A plus B divided by 2, correct? This is the arithmetic mean. Okay, now one relation what you have to know between these two is that arithmetic mean is always greater than or equal to geometric mean. This is a very important relation. That is, arithmetic mean is greater than or equal to geometric mean. So the basics of what is a geometric progression, what is a geometric series, because geometric series is where we have plus 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 in between. Right? So geometric progression, geometric series, and what is geometric mean. We discussed about these things, correct? Now in the next video, we'll solve problems on the topics what we have learned in this particular video.